Welcome to PICK Computer Science video number 37, looking at data types. So, why do we use these things called data types? Well, us as human beings, when we see some data, we would probably know what type of data it is just through our natural instinct. So we can see that the number 14 there is an integer whole number, and the text winner is a string data type, and the value 16.79 has decimal places involved, so would need to be stored with a data type that allows for decimal places. A computer doesn't have the luxury of knowing types of data when data is input into it. That is why, as programmers, we must establish data types for different sorts of data so that the computer can process that data. As a programmer, when declaring variables, constants, we're already used to using data types. The examples there, integer and string. But also when we are coding subroutines, and parameters within subroutines require data types, as with this function here. The function itself needs to have a data type because it returns a value. So we're used to seeing and using these data types already. Key things for your exam that you'll need to know about data types are the 6 main data types that the exam board recognise. And there they are on the left hand side. Integer, real and floating point, which allow for the storage of decimal places. Character, which can store a single letter, symbol, number, or other sort of data that can be stored in one single space, a string, which can store multiple characters, and boolean, which can store only 2 possible values, true or false. So you'll want to pause the video at this point and just make sure that you know those definitions. What is also worth knowing is the amount of space in bytes that each data type requires. As programmers, we want to make our programs as efficient as possible and to use as little memory as possible, so it's always worth knowing which are our data types that take up the least space, the most space, the ones in the middle, so we can make efficient programs. And that's why we don't always just use string. A string can store anything and any number of characters, but is our most expensive data type in terms of memory. So an integer, depending on your programming language, would require 2, 4 or 8 bytes of space in memory, and it's always best to go with 4 as a number because that's in the middle, and if you ever had to do any calculations, then that's your best bet. Real or floating point data types require 4 or 8 bytes, so again 4 is a good number to use for any number data type. A character requires 1 byte. A string requires 1 byte per character, and when we learn about ASCII and character sets, it'll become clear as to why that is. But that stands to reason. A character 1 byte and a string 1 byte per character. We would say that a boolean, although it can only have 2 possible values and therefore could be stored with 1 bit of data, either a 1 or a 0 is what is needed to be stored, and we can store either a 1 or a 0 in a bit, we would say that it requires 1 byte, which is actually 8 times as big as a bit. But if we're dealing in bytes and not bits, then we'd have to say 1 byte. I'm sure I haven't confused you there. Other key things for the exam might be a definition of data type itself. A data type is a formal description of the kind of data being stored or manipulated within a program or system. And then we could give some examples such as alphabetic or numeric data. Another interesting thing is to know about primitive data types. These are the basic data types provided by a programming language as building blocks. Most languages allow more complicated composite types to be recursively constructed starting from basic types, e.g. char, integer, float, boolean. That's quite a grand sentence. What that basically means is that we have simple data types such as char or character that then behind the scenes allow us to create such data types as strings. And that's what that last sentence there says. One very key thing that you'll need to know about is something called casting, and this appears in the exam board pseudocode guide. Casting basically means being able to transform one type of data into another. So if we had a number data type such as an integer and it stored 3, we could convert it into a piece of text, a string, by using the command str parenthesis 3 parenthesis, and we could then convert the string value back into an integer again with the int command. And then there'd be the float command to convert some text into the value, numeric value of 3.14. Now, some of these casting commands differ from what you see on the screen at the moment to what's in VB.net, but you can have a play around with those for yourself. Some further reading or tasks for you would certainly to be having a look at exploring all of the different data types that are available in VB.net. Some of them are key to the exam board and some of them really aren't, but they're still worth having a look at and thinking about the amount of numbers or characters that you're able to store in each, and maybe trying to break each data type. So declare a variable with all these different data types, see what you can store in it, and maybe fill out the sheet. You could also have a go at some casting. You could recreate a program like this, and we can see we've got some of our casting commands within this program. One of the sort of things you might get asked about in an exam with regards to data types is where we're given a description of some variables and asked to identify which data type would be best suited for those variables. In years gone by, you might be asked to also identify the size that would be required in memory for those data types, and then to work out how much size in total would be needed for a certain amount of records, say 100 records, including a 10% overhead. So you could have a practice at some questions like that. You might have spotted where this student actually dropped marks. Look towards the top of their answer here and see if you can see why there's an error in there. Hope that was useful, and we'll see you in the next video.